Hi. So again, coming back to sulfuric acid. So this is the third PPTs. So in first two PPTs, we cover up the process of manufacturing of sulfuric acid in two parts, basically three parts. First was sulfur to sulfur dioxide. A second part was sulfuric SO2 getting converted to SO3, and SO3 is getting absorbed to H2SO4 to get oleum. So in this particular process, we talk about the two process, basically a lead chamber process and a double contact double absorption process. So why our other process are developed on a first one? So as we discussed before, these are the specifications required of acid. Now in early 19th century, there was need, and then the first process came out, which was a lead chamber process. And after that, the problem with this particular process is it has very low conversion, maybe around 11 to 12% maximum conversion. So then research developed another process which converted SO2 to SO3, and SO3 can be absorbed into H2SO4 with a help of catalyst. So first it came with a platinum catalyst, but then the catalyst has a problem that it easily gets poisoned with the contaminants, arsenic, sulfur, SO2. So then they came out with another catalyst, a vanadium pentoxide on alkali metal oxide porous carrier containing silica. So this catalyst is more stable towards the contaminants compared to a platinum catalyst. So that's why now on commercial scale people are using vanadium pentoxide as a main catalyst. So this is called as a contact process. So there is a single contact process, a double contact process. We'll see how the processes are developed. So this is the main reaction as we discussed in previous slides. Now let's look at here. In case of lead chamber process, it was basically SO3 directly getting in contact with H2O to get to H2SO4. Now in this case, if you directly contact SO3 with water, it will form a type of fog, and it get just SO3 get dispersed into a mist of water, but there is no the conversion or reaction of SO3 with water is very slow, which will give only 11 to 12% of H2SO4. So initially whatever H2SO4 is produced, it is produced by this process, and henceforth a same H2SO4 is used to absorb SO3 to give you oleum. So you can see the reaction where SO3 can be absorbed into H2SO4 to give you oleum, which can go to 98. So basically absorption of SO3 sulfur trioxide into H2SO4 to give 98.5% sulfuric acid. Now if you see a oleum, you can define oleum as a concentrated sulfuric acid, and very easy to get back to H2SO4 by just adding water. So it will have a two advantage. One, in terms of transportation, you are saving money because you are transporting a concentrated sulfuric acid. So if you see a concentration of H2SO4 in oleum will be more than 100%, and in storage you require a small storage compared to having a weak acid. So anytime you require H2SO4, just add up water and you will get a desired concentration of sulfuric acid. You can see here lead chamber process will only give maximum 12% of H2SO4 concentration conversion, which is very poor. So that's why there is a single contact and double contact process which was developed. Now, advantage of a double contact, double absorption processes, because of you have seen in previous videos there are 4 beds. So at double contact 4 times you are having a reaction. So 2 beds are operated at one time, so 4 beds double contact, which will ensure a maximum conversion of SO2 to SO3. But at the same time there is absorption. Now as SO3 amount is increasing in the reaction, your rate of backward reaction would be more compared to a rate of forward reaction, which is not feasible. So we need to remove the SO3. So that's why the first absorber used, which will remove a maximum SO3 which is formed in first 3 converters. And then as the maximum amount of SO3 is absorbed, the 4th converter is used to convert a remaining SO2 to have favorable reaction on the right hand side, as there is very less SO3 or no SO3 available into a right hand side. So the second advantage is, that's why there is a second absorber. And advantage with DCDA process is you can have a very less amount of unreacted SO2 to be let off in atmosphere. So you can follow a regulations given by a pollution control board in terms of how much SO2 you can release into atmosphere, which should be minimum. So you can look at the contacting equipments. Now when you look at the absorption, what is important is the contact of gas and liquid should be very good. Better the contact, better you can find absorption of SO3 into H2SO4. So these are the packing, the saddle packing which are used to contact. Also different types of catalysts which are used. You see your oleum catalyst into a different form. So here again the surface area will play a role to convert more SO2 to SO3. So we discuss first process, sulfur to sulfur dioxide. Second PPT we discuss SO2 going to SO3 and SO3 getting absorbed to H2SO4. This particular PPT we looked at what is the difference between lead chamber process and a double contact double absorption process. It evolved so that we get around 99.5% of H2SO4 produced as the products. So we can say we are trying to utilize the resources very effectively and reduce pollution by the process. Thank you.